If you remember the previous videos, we talked about LEDs, right? LEDs are light emitting diodes. They basically turn on and off depending on the signal that they get. Now, typically in a digital signal, you have two options. You basically have on or you have off, right? There is no in between. You're not going to get a 0.5, it's either 0 or a 1. That can be very useful for certain types of things that you're trying to do. However, if you are trying to create a different sort of application or a different use case, then you might want your LED to be able to go from 0 to 100 in terms of brightness. For a digital signal, you'd either have 0 or 100. You'd not have anything in between, which means you cannot increase brightness, you cannot increase speed. It would either be 0 or 100. However, in these scenarios, you can use an analog signal. So analog signals allow you to create a range of values between a minimum and a maximum. So if your minimum is 0 and your maximum is 100, an analog signal can let you have a value of 5, of 10, of 20, of 30, or 100. Whereas with digital, you'd either have 0 or 1. It's like when you switch on the bulb in your house. The bulb is either on or off. You'd need something special to dim the bulb. So you'd need something in between the power and the bulb to allow you to dim the bulb from fully bright to fully off, right? So today we are going to explore the difference in those. We are going to use the LEDs. This particular LED, we will learn how to fade it in and out to increase brightness. Right now you see it's just going on and off, representing a digital signal. So just to recap, if we look at our code, we have the pin mode. We have our setup, which runs when we press the reset value. I'll just remove this because this is not necessary. So you have pin mode being set as pin. We have pin number 13 being set as an output using the pin mode command. And then in the loop, which is the function that runs over and over again, we are looking at pin number 13 and sending it a digital write command and telling it pin number 13 should be high. And then we are delaying or waiting for 1000 milliseconds, which is 1 second. And then we are sending another digital write and telling pin number 13 to go low. And then we are delaying for another 1000 milliseconds, which is 1 second, and turning it off. So this code here is basically what's making this thing turn on, off, on, off. But what if we wanted it to have, you know, like this gradual on and then like keeps getting brighter and brighter and then gets like maximum brightness and then goes off all the way down, right? So to do that, we need to simulate an analog signal using digital signals. All right, so bear with me here. So for this, we're going to use something called pulse width modulation. Pulse width modulation is, in short, it's called PWM. It's a way of faking analog signals using digital information. So what happens is that you send a series of digital signals in terms of on, off, on, off, on, off in such a pattern that allows you to have an average amount of power. Right? So if you have a device like an LED that is expecting a certain amount of power, if you turn a signal on and off, if you turn it on and off fast enough, you'll notice that it's very dim because the average amount of power that it's getting is low. Right? If you turn it on and off slowly, it gets brighter because the average amount of power is high. So the way the PWM works is that it varies the number of digital signals being sent to the device, in this case, the LED. It varies the speed and the time of those signals in order to create an average value. Now, because this is happening really fast, remember that the Arduino board works at about 16,000 instructions per second. Because this is really fast, you're not seeing the times when it's on and off. You're just seeing this steady value, and that steady value has an overall analog value that is dependent on how quickly the signals are being sent and for how long they're being left on. So in order for your Arduino to be able to use a PWM signal, it needs to be connected to a PWM pin. A PWM pin, they are marked on the Arduino and they have this little symbol. It's called a tilde, which is basically like a wave, right? It has this little signal. Every single pin that has that signal is a PWM pin. What this means is that any one of those pins can be used to simulate an analog signal as an output. On this other side, you have analogs that are in. So those read analog signals. But these specific ones that have the waves next to them can simulate and output virtual analog signals. All right? So now in this case, we are going to use one of these pins, pin number 9. So our connection will basically be, you'll have a pin, you'll have a wire coming from the ground, which again, if you remember correctly, is our negative. So it will be coming from the ground, going to this rail on the breadboard. If you don't know about breadboards, please go watch one of our first videos, you'll see them there. Coming into a resistor. Resistors are controlling the amount of power that goes into any device, in this case, the amount of power that's going into the LED. And then going to the LED, and then the other side of the LED is connected to pin number 9. So that's our schematic, right? If you come back here on our board, you'll notice that there's nothing happening with our LED because we have not told it what to do with pin number 9, which is the new place that it's been connected to. So let's look at pin number 9. Let's make some connections to it. So at this point, we will create a variable called integer and assign it the value of 9. So again, watch the previous videos about variables. This, we're just basically saying there's a specific thing called an integer, and we're giving it the current value of 9. So this is useful because we're going to refer to it later. In our setup code here, we're going to set pin mod, and we're going to say pin number 9 and assign it to be an output. That means that pin number 9 can only send signals, it cannot receive signals. Let's remove that to keep this clean. And so now we're going to introduce a new command called analog write. Remember, previously we've been dealing with digital write. Now we are talking about analog write, and then analog write is expecting 2 parameters. One of them is what are you writing, where are you writing. In this case, you're saying writing to pin number 9, and then it's expecting a value. So in this case, let's give it a value, an arbitrary value of 100. And save this. Yeah, we have an error here. So I forgot to tell it what I was doing. Actually, no, let's just remove this whole thing because we don't need it right now. Because we're not going to use the variable name. We're just going to use the pin name. So just to keep our code nice and simple, we'll just use the pin name instead of the variable name. Upload. And so now we have our LED, it's lighting. But it's receiving an analog signal, meaning that what's happening right now is that the analog pin is sending a really large number of instructions to the LED, telling it to turn on and off in a specific pattern and for a specific amount of time in order to make it look like it has a certain amount of brightness. So because it's sending that signal in a specific pattern, it is creating an average value for the power that the LED is receiving. All right, so let's take a quick look at how PWM works. So imagine that you have a chart, right? This side you have voltage, in which this is 0. So you have voltage, and this is 5. So when it's down, when your signal is down here, you're basically getting voltage of 0, which means nothing. When it's up here, you're getting a voltage of 5, which is the maximum, all right? So the way that the PWM works is that it sends a series of signals, and how those signals are structured is called a duty cycle. So for example, if you remember our LED, when it's blinking on and off, if it sends a signal and says blink at 5 and then turn it off, so maximum, and then a few seconds after one second, turn it on, then maximum, turn it off, turn it, wait for 5 seconds, turn it on, maximum, turn it off, like that. like that. So for half the time it's on, for the other half it's off. So here it's on, getting maximum power. Here it's off, getting 0 power. Here it's on, getting maximum power. Here it's on, here it's off, here it's on, etc. So the average power that the LED is getting is actually, because it's on for half the time and off for half the time, the average power that it's getting is 50%. All right? So that means that its brightness will be at 50% of its maximum brightness. If we did the same thing and sent another series of signals, and we said turn it on, and instead of turning it off, you'd make it stay on again, 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 make it stay on again. There's nothing happening to bring it back down, which means that at this stage, at every single stage of this process, of this bit of code, it's actually receiving maximum amount of power 100% of the time. So in this case, the brightness will be 100%. Now, if we give it another scenario and say 0 volts, 5 volts, and in this case we tell it turn on for just 25% of the time, and then off for 75% of the time, turn on for 25% of the time, and then off for 75% of the time, on for 25%, off for 75%, on for 25%, off, right? So you'll notice that the maximum power that the LED is getting is only for 25% of the time, and 75% of the time it's off. So in this case, you're getting power only 25% of the power. So this 25% will be much lower. It will look much lower than the 50%, which will look much lower than the 100%. So the LED at this point will be very dim. The LED at this point will be sort of bright, and the LED at this point will be maximum brightness. For the people who want to explore the technicalities, this entire process is referred to as the duty cycle. We'll not jump into those details, but this is what you need to understand why the LED looks like it's on, and when I change that value, you're going to see why it looks like it's off. All right? We got deep there, but I hope you're still with me. All right. So now we are going to look at our code and see how changing this second parameter, which is basically the amount of brightness, will affect the brightness of the LED. The other thing to remember about analog signals is that in Arduino, typically it will range from 0 to 255. I won't go into the details of why that is. That's a more advanced topic. But just know that generally you're looking at a minimum of 0 and a maximum of 255. So any number in between there will represent a range from 0% to 100%. We'll take a look at it shortly. The other thing to keep in mind is that because of how LEDs are designed, you might see more of a difference on one side of the scale than on the other side. And this is all about, this has to do with more like how the tolerance is, the manufacturing process of the LED. So you might see that on the lower ends, you see a bigger difference when you change the brightness, and on the other end, you might not see a bit of a difference. But again, we'll look at the examples and you'll see for yourself. So right now, this is at 100, which means that on a scale of 1 to 255, it's sort of halfway in between. If we put it at 0 and upload, you should see nothing, right? Which means that the way that the signal is being sent to the LED from the Arduino means that the LED is not getting any sort of recognizable power. If I amp this up to 10, we might see it get a little bit brighter. See that? If I amp it up, if I reduce it to 5, you'll see it get a little bit dimmer. If I say 2, even dimmer. But if I say 255, which is the maximum, and you'll see how bright it gets. So if I do 50, so you're able to see these differences on the lower end of the spectrum as opposed to the higher end. Because I think to our normal eyes, anything above 150 might not be easily discernible. The point is, now the Arduino is sending an analog signal to the LED, which means it can tell it to be fully bright, 10% bright, 30% bright, 69% bright, 20% bright, 78% bright, whatever value that you want. And in this case, we are mapping it from 0 to 255. So any number from 0 to 255 will determine the brightness. Let's explore that a little bit more so that we see how the code would vary. So in this case, we are going to just create a series of transitions from one level of brightness to the other. So you can say delay 500 milliseconds, which is about half a second. Analog write, pin number 9 again, and say maybe 5. Then do another delay, 500, and then do another analog write, pin number 9, maybe say 10. And let's just copy and paste this so that we have at least 5 values that we are looking at. All right. All right. So we have analog write, means it's sending a value of 0, a value of 5, a value of 10. Let's give it a value of 50, a value of 75. No, let's give it 100. And a value of, let's say, 210. And then give it one final delay so that we can actually see the 210. And upload this. So if this works, you're going to see the LED gradually go bright and then turn off and then gradually go bright again. Moment of truth. Right. It's pretty cool, isn't it? So that's basically a series of analog signals that are being sent through the PWM pin. They're actually a series of digital signals that are being simulated through the PWM pin and being sent out to the LED as analog signals, right? So obviously, it would be nice to find a way to not have to do this manually, because imagine if you're doing this from 0 to 255, you're going to have to create 0, 1, 2, 3, 4, 5, and just repeat the entire thing all the way to 255. You're going to have basically 500 and something lines of code just to turn this on, just to fade it up. And then if you want to fade it down, you're going to need another 500 lines of code to bring it down. It's just not practical. And yet you can do it with something like 3 or 4 lines of code. So in one of our next videos, we're going to look at how you can simplify code like that using things like loops. So basically, like a for loop will say that for as long as this thing that you're looking at is between a certain value and a certain value, in this case 0 and 255, add one more number, change another value based on that number that you just added, and then go back and repeat. So for loops are the cornerstone of programming, and we'll take a look at that separately. That's it for this video. I know it's been short, but I hope it's been very nicely useful. We've introduced 2 major concepts. The first is simulating an analog signal using PWM, and then the second is a little bit more clarification on the difference between digital and analog signals and how you can use an Arduino board to create those differences. So the Arduino board is a really powerful board, and as we keep going along with these tutorials, I hope it will help you understand how powerful it can get. So see you in the next video. Thanks for watching. Bye.